Okay, I'm letting the soldering iron warm up, so I thought I'd talk just very briefly about the PT, the power transformer. Sometimes people that didn't work in the electrical or electronics industry tends to be a bit of a mystery for them, and maybe I can just kind of help this out. This is more for people that are newbies. Other people say, well, you didn't include enough or don't say enough. That's not really my point. I don't sit down and think about what I'm going to do in these videos. It's just as I'm getting ready to start the next step, it's kind of like, what should I have said or included or told somebody that's building one of these? So anyhow, this is the power transformer for this particular build. Of course, my output transformer is mounted top side. These are the two leads for this. This is the primary lead and this is the secondary lead. And this is the choke, of course. All transformers have a primary lead and a secondary lead. Okay, what's that mean? Okay. If you think about how a transformer actually works, is you have a coil of wire around a iron core that is made of lamination stacked on top of each other, because a solid iron core doesn't work that well for a magnet. What happens is, on your primary side, your voltage comes in, it goes around that coil of wire, which acts like a gigantic resistor of sorts. And because current is flowing through that coil of wire at a right angle, it's going to impose into that steel core magnetism. Because current flowing through a coil of wire wrapped around a piece of malleable steel becomes a magnet. These cores are usually arranged in kind of a big block, kind of like a big rectangle with an open center on them. So on one side you get the primary coming in, you got your wraps around it, it makes a magnet. The magnetism flows through that iron, comes around the other side. On the other side you have, on these particular tube amps, you'll have a minimum usually of 3 individual sets of coils of wire, and that magnetism will then at that point induce voltage back into the wires. So on the primary side, you take the voltage that's there, make magnetism. Secondary side, magnetism makes voltage. Works just ass backwards to what the primary side does. And it's kind of like, okay, well, how do you decide of which is going to do which? As far as my top side say is, which is these 2 black wires right here. That's my 120. This particular one happens to have a 120 primary. Some of them will have 240 depending on the rating and stuff like that. And on the secondary side, I'm going to come over to this is a classic tone power transformer, by the way. It's a 40-18041, which is 180 milliamp. That's how many milliamps that is capable of producing for your V plus. And then the voltage that's coming out of the secondary side on this particular one is 650 volts. So it's 325-0 because it's center tapped, which is this red yellow wire right here, because the primary taps are, or secondary taps, the HT taps are these 2 red wires right here. So if we come over here and take a look at, here's a picture of this particular power transformer. Here's your 120 side right here. Shows your winding. It's winding around. This is your laminations that I just talked about, your iron core laminations. I don't know enough about transformers to tell you how many, what type, how they're stacked, and all that shit affects the magnetic properties of the transformer. I'm not going to get into that. There's people that know a lot more about that than I do. Hurts my head bad enough to think about the way it is. On the secondary side, this is the secondary side right here. You have 3 distinct sets of windings. This is a set of windings on this iron core. That's the second set of windings on this iron core. That's the third set of windings on this iron core. Each of these three sets are independently wound on that iron core. You could theoretically burn out one of these sets and the other two sets could still be fine, theoretically. So on this particular one right here, it shows 650 volts with a center tap. My center tap right here is red yellow. So between this red and this red and yellow is 1/2 of the 650 volts. So that's 325 measured from here to here, 325 measured from here to here. If I measure across this whole coil of wire right here, it's 650 volts. Notice also in the middle of this coil there is a tap that is red/green. That is a strategically placed in that coil to produce 50 volts, which will be my bias voltage to go to my bias circuit. Come down to this one down here. This set of coils right here does not have a center tap because the 5 volt doesn't need it. It's 5 volt, and this is rated at 3 amps. 3 amps is more than sufficient for 5 volts because an octal rectifier most of the time uses 2 amps. Usually the most 5U4 I believe is a little over 2.5 amps. So 3 amps is fine for that. The reason I went with this particular transformer was because of the primary voltage up here, which I needed. I need to be close to 330 volts. This is 325. I'll explain this in a minute. But also on my filament heaters, this is my heater coil right here. It is center tapped also with the green and yellow. So from here to here, I would measure 6.3 volts. If I measure from here to the center tap, it's going to be 3.15 volts. Notice it's rated at 4.5 amps. This is a more robust tap or coil, as you would speak of here, to allow me 4.5 amps for my filament string because I've got 6 preamp tubes and 2 6V6 power tubes coming off this particular indicator light coming off this particular set of coils. Okay, so if I'm not going to do all the math on this, if you're looking for, okay, what sets up this particular power transformer different than others, if I've got 120, if I divide 120 into 650, talking about this out here, I'm not talking about the center tap, on this right here, 5 by 120, whatever that comes out to be, which is 4. Hang on a minute. $650 divided by 120 equals 5.41. So on what does that mean? That means that for every one turn of wire on one side, on one coil, there is 5 point, whatever in the hell I just said it was, 4, I believe, turns on the other side to give you this particular ratio of 120 volts to create 650 volts on this side right here. What perplexes a lot of people on this power transformer is they say, okay, where's my DC voltage? There is no DC voltage on this power transformer right here. This power transformer is AC voltage. It's taking 120 volts AC right here and converting it into 650 volts with a center tap right here. AC, again, 5 volts AC, again, 6.3 volts AC. This is AC to AC is what this transformer does. That's all it does. You do not develop DC voltage until after you go through your rectifier. Whether it's a rectifier tube or solid state diodes for your rectification, that's when you make your AC turn into DC for your B+ voltage. This, in the meantime, is always going to stay the same because this is your filament for your power tubes and your preamp tubes, which is AC. It's always going to stay AC. On some amps, you'll say, on high gain amps, they say, oh, well, my first couple stages of my preamp tubes are DC voltage. Yep, they developed a separate power supply for that. But on most all of them, when you buy a power transformer like this, it's AC in, AC out. You develop your DC after your rectification. So that's all there is on these to think about on these. If you add up the current value of each particular tube, you'll end up coming up with your milliamp value. This one is overrated. Typically, most people will build a 6v6 tube amp with around 120 volts milliamp. I think Leo actually cheated a little bit, went down to about 100 amp or 100 milliamp, and that on some of his, and it drew him way down. The higher the milliamp rating, the less taxing it is on your power transformer, so it runs a little cooler. The reason I went with this particular one is this particular one offered the 4.5 amps for the filament, which I need. And this extra amount right here, as noted in one of my previous posts, will allow the owner, if he so decides he wants to try it, to try 5881s, or which is about 137 milliamps, or if you want to actually try a 6L6GC set of tubes, power tubes in there, so I think 167 milliamps what the calculator comes out to be on that, and so you have plenty of milliamps available for this. This coil is rated for the B plus only. The 180 milliamps is not the whole transformer, it's this coil only. This coil has its own power consumption rating. This coil has its own power consumption rating. So you want to make sure that you don't get that confused, where you think that all three of these have to add up to 180 milliamps. That's not the way they build these. And so if I come over here and look at the actual transformer itself, these green leads right here, big fat green leads rated at 4.5 amps. This is my heater string. These two yellow ones right here are my 5 volts for my rectifier. It says green and red and green for the bias. That's this one right here. These are my two reds, which are my HT. HT stands for high tension. The HT is merely the secondary coil that is the highest voltage, and that's the one that powers your B plus. So these two here, measured to this red and yellow wire right here, give me 650 volts across these two, or individually measured one of these to this red and yellow wire will give me 325 volts on that. The same with for my heater string right here, it's 6.3 volts across the two, or if I'm measuring either one of these to the center tap right here of the green and yellow wire, I'm going to get 3.15 amps across this. This orange wire is fastened internally, and it gets grounded along with these also. It's usually identified as orange and SS right here. That gets grounded also. It's an internal shield wire, I believe. Part of the winding. There's probably somebody can explain that a hell of a lot better than I can. But basically, that's what you got for your power tubes. So I'm going to drop it at that, leave it where it is. That's just kind of brief explanation on what's going on with a power transformer. If I can get this damn thing to shut off now. I need a new phone so bad.